October 20th, 2025, a regular person with a telescope takes a picture that breaks all the rules. You're seeing the exact location NASA told us. 13 hours, 48 minutes, 57.33 seconds. -8 degrees, 25 minutes, 54.3 seconds. That's where 3i Atlas should be. But this photo, straight from someone's backyard solar telescope with no editing, shows something that goes against everything we know about space rocks. There's a shape, a heat shield aimed right at the sun, a dark center with backwards colors, a weak cone-shaped cloud going the wrong way. And here's what should worry you. There's no tail. Every space rock you've heard of has a tail. It's not a choice. It's basic science. Solar wind blows gas and dust away from the sun. Always, no matter what. So what are we really seeing here? The thing currently hiding behind our sun, the one showing up at the exact right time for a path change, the one releasing factory metals we've only found in human spaceships, just got caught, doing something that shouldn't be possible. And today we're going through every clue, every idea, every chance of what October 29th might reveal when this thing gets closest to the sun. If you find this as interesting as I do, like and follow. Then comment where you're watching from, what time it is. And honestly, do you think this is natural or something different? And if you want to help our group spread, share this on X, Facebook, Reddit, or your chats. Thanks for always supporting us. The picture that changes our understanding. The photo appeared online at 4 p.m. World Time on October 20th. User Dobsonian Power. Just a regular person with a solar telescope. Nothing special, nothing professional, just someone who knew where to look and had the skills to watch things near the sun when every big space center has been oddly silent about doing the same thing. The picture shows 3i Atlas at a distance where it should be acting like a normal space rock. We're talking about something that's been coming toward our sun for months. Warming up, supposedly releasing gas, building that familiar tail that every space rock creates when sun rays turn ice into gas. That tail should be clear. It should be big. It should be pointing away from the sun like a flag in wind, because that's how science works in our solar system. But that's not what we're seeing. What the picture shows is a forward-facing stream. The person who posted it called it a heat shield. This stream is aimed right at the sun, not away from it, toward it. And before you think this might be some camera trick or mistake from the photo process, remember, this is a solar telescope made specifically to watch things near the sun. The colored spots spread across the picture, those are hot and cold spots from the camera. Normal interference you'd expect. But that stream shape, that's real. The center looks dark in the backwards color method the watcher used. That's normal for this kind of sun photography. What's not normal is the missing cloud of activity you'd expect from a space rock at this distance. There's a weak, spread-out puff. Yes, the watcher said it goes toward the top left of the picture. Small, limited, nothing like the huge cloud of gas and dust that should be around an active space rock this close to its nearest sun approach. Let's explain what we know about space rock science. When a space rock comes near the sun, sun rays heat its surface. Ice turns to gas. Water ice, carbon dioxide ice, carbon monoxide ice. These materials don't melt like ice in your glass. They go straight from solid to gas. That gas takes dust bits with it as it leaves the space rock's weak pull. This makes the cloud, the fuzzy air around the center. Solar wind and light pressure then push this stuff away from the sun, making the tail. Sometimes to tails. A dust tail that curves a bit along the space rock's path. a charged particle tail that points straight away from the sun, blown by solar wind like hair in a storm. This process is so dependable, so well known that we can guess what a space rock should look like at any distance from the sun based on its size and what it's made of. We've been watching space rocks for thousands of years. We've sent ships to them. We've landed on them. We understand space rock behavior like we understand how water heats up or how metal gets. Rusty 3i Atlas isn't following the normal pattern. The person who posted this picture said clearly that they'll use a regular telescope in November after closest sun approach to watch it live. Think about that wording, after closest approach, after it goes around the sun. That tells you something about how they're watching. Solar telescopes are the only way to see things this close to the sun from Earth right now because the brightness would overpower any regular telescope. So we need special equipment and the few people who have it and know how to use it. Which brings up an obvious question. Where are the professional pictures? Where are the photos from the big space centers? We know they have the tools. We know 3i Atlas's location, they can figure out exactly. So why is a backyard watcher giving us the most recent visual proof of what this thing actually looks like? The timing is important here. We're on October 21st as you're hearing this. Yesterday's picture shows 3i Atlas in a setup that doesn't match what a space rock should be doing. Today, right now, 3i Atlas is at solar meeting point. It's directly on the far side of the sun from Earth, perfect hiding spot. And in 8 days, on October 29th, it reaches its closest sun point, the moment when a natural space rock should be most active, the moment when, according to Harvard space scientist Avi Loeb, a technology item would perform a path change to get maximum energy from the sun's pull. Let's discuss what we're actually seeing in this picture, part by part. The stream pointing toward the sun. In space rock science, we do sometimes see streams. They're focused releases from specific spots on the center where ice is actively turning to gas. These streams can point different ways depending on how the center spins and where the active spots are. But they're part of a bigger gas release pattern. They add to the overall cloud and tail structure. What we're not seeing here is that bigger pattern. We're seeing a directed stream and not much else. Some researchers have suggested that 3i Atlas shows what they call a backward tail, something that seems to point toward the sun instead of away from it. Backward tails are known things. They're visual tricks caused by viewing angle. When Earth passes through or near a space rock's path plane, the dust tail can seem to point toward the sun because we're seeing it from the side. Like looking at a plate from the edge instead of from above. The shape looks totally different, but a backward tail is still part of a tail structure. It's still part of huge gas release. It's still surrounded by a bright cloud. The October 20th picture doesn't show that. It shows a focused stream and a small puff and a dark center and very little else. The dark center itself is interesting. In backwards color sun pictures, bright things look dark. So the center looking dark tells us it's reflecting or releasing light. But the strength and spread of that light isn't following the expected pattern. If this were a normal space rock center, we'd see it surrounded by a bright shell of cloud material in this picture style. The cloud would look like a spreading glow, slowly fading as you move away from the center. Instead, we're seeing clear structures, the stream, the puff, shape-based features rather than spread out clouds. Now, let's talk about the obvious concern. Could this just be bad picture quality? Could the telescope's ability be too weak to catch the smaller details of the cloud and tail? Let's think about that. Dobsonian telescopes, when properly set up for sun watching, can see good detail. They're not professional level, true, but they're not toys either. The user clearly caught the center. They caught structure around the center. If there was a big cloud and tail, those would be the brightest, most obvious parts. They would appear even in a low-quality picture. Think of it like taking a photo of a street lamp on a foggy night. Even with a cheap camera, you'd catch the glow. You might not get sharp detail, but you'd get the glow. We're not seeing the glow here. Could air conditions explain it? Wind movement, clouds, moisture, maybe, but unlikely to completely hide major structure parts while still letting the center and stream be caught clearly. Air effects make things blurry. They don't selectively hide things. Could the timing of the watching matter? Maybe 3I Atlas was in a temporary quiet period. Space rocks can change. Their gas release can pulse as different parts of the center spin into sunlight or as hidden ice gets exposed. But we're talking about something days away from closest sun approach. This is when space rocks are most active. This is when they're brightest, most busy, most dramatic. A quiet period right now would be like a pot going silent just before it boils. Possible, but weird. Let's step back for a moment and think about the bigger picture. The first atlas has been unusual since discovery. The list of strange features keeps growing with each look. It started glowing way earlier than expected. It showed an unusual makeup with extremely high carbon dioxide compared to water. It displayed that backward tail structure pointing toward the sun. Recent light analysis showed nickel releases without matching iron, a signature linked with factory metal processing. Its path brought it into the solar system, lined up with Earth's orbit plane, statistically rare for a random star visitor. Its starting direction points within 9 degrees of where the famous WOW signal was found in 1977. Each oddity alone can be explained. Statistics will create rare events. Makeup varies among space rocks. Viewing angle creates visual tricks. But when you pile oddity on top of oddity on top of oddity, at some point you have to think about whether you're forcing a natural explanation onto something that might not be natural. The October 20th picture adds to that pile. It shows something that should be showing obvious space rock behavior and isn't, or at least isn't showing the behavior in the expected way. Think about this for a moment. Imagine you're watching water in a pot on a stove. You know the heat is on high. You know the water should be bubbling, but when you look, the water is calm. Maybe moving slightly, maybe flowing in odd patterns, but not bubbling. Your first thought might be to question what you're seeing. Maybe the angle is wrong. Maybe the lighting makes it hard to see the bubbles. But at some point, if the water keeps not bubbling, you start questioning what you thought about what's in the pot, or whether the stove is actually on. You change your understanding of reality to match what you're seeing rather than ignoring the observation because it doesn't fit your understanding. That's where we are with 3I Atlas right now. We expected a space rock. We built our guesses on space rock behavior, and reality keeps giving us something that doesn't quite match those guesses. The person who posted the picture said they'll watch again in November with a regular telescope after closest sun approach. That's when 3I Atlas will come out from behind the sun and be visible from Earth again. That's when we'll get another chance to see what it looks like, what shape it's in, whether it survived closest approach, whole, or broke apart as a weak space rock center should when hit by the sun's pulling forces and strong heating. But November is still days away. Right now, today, 3i Atlas is behind the Sun, hidden from our view at solar meeting point. And tomorrow, and the next day, and the day after that, it will be climbing toward closest approach, toward that moment on October 29th, when it gets maximum sun energy, when, if it's technology, it could do the most energy-saving move possible, when, if it's natural, it should put on the brightest show of gas release and tail growth we've seen from it yet. We won't see that moment directly. Earth telescopes can't see through the Sun, but we'll see what happens after. We'll see what comes out from behind the Sun in early November. We'll see whether this thing falls apart, as Loeb said a natural space rock should, or whether it stays together and maybe releases something, as he suggested a technology item might. The October 20th picture is important because it's the last clear view we have before that hidden window. It's the starting point, the before picture. And what it shows is something that's already not acting as expected. Something with a forward-facing stream and minimal cloud, no obvious tail, and a structure that looks more clear, more geometric, more purposeful than the messy gas release of a natural ice ball being heated by a star. One more detail worth mentioning. The watcher specifically said this is a 100% raw picture, not edited. In space photography, editing is common. You combine pictures to reduce interference. You adjust brightness to show weak details. You remove backgrounds. But raw pictures are valuable because they show what the camera actually caught without improvement or changing. No editing means no fake parts added by computer programs, no computer decisions about what details to highlight. Just light hitting a sensor and being saved. That raw, unedited nature makes the missing big tail even more important. If there was a tail, even a weak one, it would appear in the raw information. Tails are bright. They spread sunlight well. They're made by science to be visible. A raw picture should catch them easily if they exist. The cone-shaped puff toward the upper left that the watcher mentioned is interesting too. Small, focused, not the ball-shaped spread you'd expect from gas going out equally in all directions. More like a directed release, like something being pushed out in a specific direction for a specific reason. We've reached a point where the question isn't whether 3i Atlas is strange. It clearly is. The question is whether that strangeness fits within the wide range of natural possibilities for traveling, space rocks, or whether we're looking at something our current understanding doesn't cover. And that's what makes the next 8 days so important. Whatever 3i Atlas actually is, it's about to face the strongest conditions it's met since entering our solar system. The Sun's pull will be grabbing it with maximum force. Sun rays will be hitting it with maximum strength. If it's a weak collection of ice and dust held together by small forces, it should break apart. If it's something stronger, something made to handle these conditions, it won't. We'll know soon. The countdown is going. October 29th is 8 days away. And right now, hidden behind our Sun, 3i Atlas is moving toward that date, carrying with it all the questions we haven't answered and all the oddities we haven't explained. And now, thanks to one regular person with a solar telescope, one more piece of proof that this thing isn't following the rules. The spreading video. This isn't a space rock. The second piece of visual proof came from a completely different watcher. User BG Gates posted deep space video with words that cut straight to what everyone watching was thinking. Latest pictures of the space rock 3i Atlas currently racing toward Earth. Just one problem, doesn't look anything like a space rock. And they're right, it doesn't. The video shows something in deep space that won't fit into any category. It's bright, stretched out. The form doesn't match what we expect from a space rock at this stage of approach. There's no obvious fuzzy cloud, no tail flowing away from the sun. What we're looking at seems structured, geometric, the kind of shape that makes your brain's pattern-finding systems work overtime in uncomfortable ways. Let's examine exactly what this video shows, and why it's creating such strong reactions from people who see it. The thing appears as a clearly straight form, not the lumpy potato-shaped mass we connect with space rock centers, not the round fuzzy ball of a cloud surrounding that center, straight with clear edges with what seems to be steady brightness along its length, rather than the messy, uneven glow you'd expect from gas and dust release. The stretching is extreme. We're looking at something where the length seems to be many times the width, 6-to-1 ratio at least, maybe higher depending on where you measure the outer edges of the visible light. Now, stretched things exist in space. We know this. Space boulders can be stretched. Oumuamua was famously stretched, so stretching alone proves nothing. But combine that stretching with everything else visible in this video, and the overall feeling changes completely. The brightness spread is remarkably smooth. Natural tumbling things in space usually show changes in brightness as different surfaces spin into view. Light and shadow play across uneven ground. Holes catch light differently than flat parts, but this thing shows an even, gradual brightness. The light doesn't have the character of bounced light off a rough surface. It looks more like release, like the thing itself is glowing rather than just bouncing sunlight. That difference is important. Bounced sunlight carries information about the surface it came from, texture, what it's made of, unevenness, released light, whether from chemical reactions or heat processes or something else, appears smooth, controlled. It doesn't have those surface fingerprints. The video shows this thing against the background stars. The stars appear as expected, single points of light, sharp, clear. But 3i Atlas doesn't appear as a point, or even as a spread-out cloudy mass like space rocks usually do. It appears as a form, a shape, something with clear structure and size. Many people who watch this video describe it using the same word, mothership. Now, that's obviously a loaded word. It suggests artificial making. It suggests purpose and design. But it also captures something about the visual feeling that's hard to shake. This looks like something that could hold other things. Something with inside space, something built rather than naturally formed. Let's work through the natural explanation step by step. Could this be a space rock center with equal gas release, creating the stretched appearance? In theory, yes. If you had a stretched center with active streams firing from both ends along the long line, you might create this kind of straight visual signature. The streams would extend the apparent length. The center would be the bright middle area. The gas would fade slowly as it spreads. But space rock streams are rarely equal. They come from active areas where hidden ice gets exposed to sunlight. Those areas are spread basically randomly based on the thing's formation and impact history. Getting streams lined up perfectly along the long line in opposite directions needs very specific conditions. Not impossible, just unlikely. And even if you had that setup, you'd still expect to see some unevenness, some irregularity, some sign of the messy physical processes driving the gas release. This video doesn't show that mess. It shows order. Could the viewing angle matter? Definitely. When you watch any three-dimensional thing, your idea of its shape depends completely on your viewing position. A disc viewed from the edge looks like a line. A ball viewed from any angle looks like a circle. So maybe 3i Atlas is actually a more normal shape, and we're just seeing it from an angle that makes it appear stretched and structured. But here's the problem with that explanation. We have many observations from many angles over many months. 3i Atlas has been moving through space. Earth has been moving in its path. The viewing position has been changing constantly. If this were a trick of viewing angle, we'd expect the appearance to change a lot as those angles shift. We'd see the thing appear to spin or change shape or show different features. Instead, what many watchers are reporting is this steady, stretched, structured appearance. Could this be a picture problem? Could the telescope or camera or processing be creating features that aren't really there? In space photography, problems are common. Light bending from telescope supports, overflow from too bright spots, cosmic ray hits on the sensor, air distortion. You always have to think about whether what you're seeing is real signal or technical interference. But problems have specific signatures. Light bending is equal and centered on bright point sources. Overflow spreads along pixel columns. Cosmic rays appear as straight lines or dots. Air distortion blurs but doesn't create structured forms. None of those match what we're seeing in this video. The form is too steady, too stable, too geometric. The other factor working against the problem explanation is that many independent watchers are now reporting similar visual features. The Dobsonian Power Solar Telescope picture from October 20th. This deep space video. Different equipment, different watchers, different picture methods, yet both show something that doesn't match standard space rock appearance. When independent observations agree on the same unusual features, you have to take that seriously. Let's talk about what we're not seeing in this video, because missing proof can be as telling as what's there. We're not seeing a big cloud. A space rock at this distance from the sun should be surrounded by a huge envelope of gas and dust. That cloud should be the most obvious feature. It should control the view. But in this video, if there's a cloud at all, it's tiny, barely visible, certainly not the huge structure we'd expect. We're not seeing a tail, not a dust tail, not a charged particle tail, nothing flowing away from the sun direction. The thing appears self-contained, complete, not losing material in the dramatic way an active space rock should be. We're not seeing the kind of uneven, fuzzy outline that marks space rock bodies. The edges appear clear. The form appears solid. There's a sharpness to it that natural things in space rarely show. Now, let's address the big question in the room. Why does this look made? Human understanding of artificial versus natural forms is deeply built in. We're pattern-finding machines. Evolution shaped our brains to tell the difference between things that grew and things that were made. Natural things have certain features, unevenness, irregularity, complex patterns. Artificial things have different features, evenness, regularity, geometric simplicity. These aren't absolute rules, but they're strong trends. When you look at this video of 3i Atlas, your brain is processing those visual clues and returning a classification, artificial. And while our gut feelings can be wrong, they're also the result of millions of years of selection pressure favoring accurate pattern finding. We shouldn't ignore that response completely. The brightness profile adds to that made feeling. The light appears uniform along the length of the thing. It doesn't flicker or pulse or show the kind of change you'd expect from a tumbling, oddly shaped chunk of ice bouncing sunlight. It's steady, consistent, like it's coming from a surface with uniform properties, or like it's being actively created. Think for a moment what a ship designed for star travel might actually look like. Not the sleek missiles of science fiction, real engineering for crossing light years. You'd want to minimize surface area to reduce drag from star to star medium. You'd want a long, thin profile to reduce exposure to cosmic rays for any onboard systems. You'd want structural strength along a single line to handle speed-up forces. You'd want heat systems that could release heat well. A stretched, structured form with even surface properties isn't a bad design for a star probe. It's actually pretty logical from an engineering view. Now, does that mean 3I Atlas is definitely artificial? No, it means the visual proof fits with that possibility. It means we can't rule it out based on appearance alone. The video also gives us some sense of how this thing moves through space. It's not tumbling messily like a typical space boulder or space rock center would. Those things are usually spinning on many lines, wobbling and spinning as they travel. This seems to keep a steady direction. The long line stays lined up with its direction of travel based on the limited motion visible in the video. That stable direction is another small oddity to add to the growing list. Natural things tumble. They don't keep fixed positions unless there's some force acting to steady them. For Earth satellites, that might be planned spin or reaction wheels or magnetic controls. For a natural space rock in deep space, there's no way for position control. They just tumble however their formation and crash history left them. So why isn't 3I Atlas tumbling visibly? Maybe it is, and we're not seeing it because the watching window is too short. Maybe it has a very slow spin rate that won't be clear until we have longer watching periods. Maybe its stretched shape means it looks similar from many angles, hiding the spin. All possible. Or maybe it's keeping position on purpose. The video doesn't answer that question for sure, but it raises the question in a way that's hard to ignore. One more element worth noting. The thing seems to be self-lit in this deep space view. It's bright against the background darkness. Space rocks can appear bright. They bounce sunlight well when they have active clouds, but this brightness has a different quality. It's not the scattered light of dust bits catching sunlight. It's more direct, more strong, like the thing itself is a light source. Could this be heat release? At the distance 3I Atlas is from the sun right now, it's getting a lot of sun energy. That energy has to go somewhere. Some gets bounced, some gets absorbed and released as infrared. If the thing has a low reflection rate, absorbing most incoming light, it would heat up and glow in infrared and even visible light levels. But the brightness we're seeing doesn't quite match that explanation either. Heat release from sun heating should be strongest on the sun-facing side and dimmer on the dark side. We'd expect to see brightness changes across the thing's surface. Instead, the glow appears remarkably even. The words with this video called 3I Atlas, a space rock, and then immediately said the opposite. It doesn't look anything like a space rock. That contradiction captures the main tension here. We have something that's supposed to be a space rock based on its path and origin, but its appearance keeps saying otherwise. How many contradictions can we pile up before we rethink the first assumption? The solar telescope picture showed no tail and a forward-facing stream. This deep space video shows a stretched, structured form with even brightness and no cloud. The light analysis showed factory metal signatures. The path lined up with Earth's orbit in a statistically unlikely way. The timing brought it to solar meeting point just before closest approach. The size makes it 1,000,000 times bigger than the previous star visitor. Each oddity alone can be explained or reasoned away, but together they paint a picture of something that doesn't fit our models. Something that keeps surprising us. Something that looks more and more like something we don't have a natural category for. And that's scary and fascinating equally. Because if 3I Atlas isn't a space rock, if it's something else, then everything about the next 8 days changes. The questions change, the stakes change, what we're watching for changes. A natural space rock at closest sun approach puts on a show, brightens dramatically, loses material, maybe breaks apart from pool stress. That's spectacle. That's beautiful. That's safe. Something else at closest approach, that's unknown. That's unpredictable. That's the moment when we find out whether 40% odds of artificial origin were too high or too low. October 13th. The number pattern signal. October 13th, 2025. The 108th anniversary of the sun miracle at Fatima, Portugal. On that day in 1917, about 70,000 witnesses reported seeing unexplained sun events during a religious vision event. The sun supposedly danced in the sky, changed colors, seemed to fall toward Earth. Group panic, air optics, religious experience. Historians and doubters have argued about it for over a century. On October 13th, 2025, exactly 108 years later, researcher David Sarita reported seeing structured light pulses from 3I Atlas, not random changes, not equipment interference, a pattern, the Fibonacci sequence. 5 pulses, 8 pulses, 13 pulses, repeating 1, 1, 2, 3, 5, 8, 1, 3, 2, 1, 34. Each number the sum of the 2 before it. The Fibonacci sequence appears throughout nature. Spiral galaxies, shell shapes, flower petals, pine cones, DNA spirals. It's the math signature of growth, of best packing, of natural efficiency. Finding it in the light patterns from a star-traveling object arriving at our sun would be amazing. Finding it on the anniversary of Fatima would be, well, choose your own word, coincidence, timing, message, warning. Let's examine what Sarita actually claims to have seen and what it would mean if proven true. The light pulses supposedly followed the pattern 5813, 3 consecutive Fibonacci numbers. Not 1, 1, 2, not August 13th, 21. Specifically the 8th of May, 13. In Sarita's space understanding system. And this is where things get guesswork. These numbers match planets in an expanded solar system model. 5 represents Earth. 8 represents a hidden planet he calls dominions or planet. 591. 13 points to another unseen world named Virtues or Methuselah. Now, mainstream space science doesn't recognize these extra planets. Our solar system has 8 confirmed planets after Pluto's category change. There's ongoing talk about a possible planet 9 in the distant outer solar system based on path changes of far objects. But Sarita's model suggests many extra bodies, some of them extra-dimensional, based on alternative and mystical physics frameworks. Whether or not you accept that space system, the claimed observation itself is worth examining. Light pulses in a math sequence from something that shouldn't be making structured signals at all. Sarita connects this to the work of researcher Richard C. Hoagland, who apparently figured out the importance of the 108-year anniversary. 108 is a frequency multiple of 432. That number, 432, Hertz holds importance in certain mystical traditions as a sacred or harmonic frequency. The math works out -108 times 4 equals 432. Whether that math relationship means anything in physical reality is a different question. The theory goes further. Sarita reports getting a vision telling him to add 432 days to October 19th, 2024. That math lands on Christmas Day 2025. December 25th. On that date, according to this model, 3I Atlas will be at its closest point to Earth and positioned at the same angle as the Great Pyramid of Giza, relative to some sky reference frame. Is this guess testable? Yes, we can figure out where 3I Atlas will be on December 25th. We can check its position relative to Earth. We can measure angles. So we'll know in 2 months whether this particular guess has any truth. But let's return to the main claim, the Fibonacci pulses on October 13th, for this to be real signal rather than pattern finding in interference. Several things would need to be true. First, many independent watchers would need to find the same pulse pattern. One person seeing patterns could be seeing faces in clouds. The human brain is really good at finding patterns, even in random information. We see faces in clouds. We hear words in white noise. We find meaning in coincidence. It's not a flaw. It's a feature. But it means single watcher reports need backup. Second, the pulses would need to show up in equipment data, not just eye observation. Light curves from brightness measurements, light spectrum changes. Something objective that many instruments could record and study. Eyewitness reports are valuable for first detection, but not enough for proof. Third, the pattern would need to repeat or show some steadiness across many watching windows. A single burst of 5813 pulses could be chance. If the pattern repeated many times over hours or days, that would be far more important. So far, we don't have that backup publicly available. Sarita's report stands alone. That doesn't make it false. It makes it unproven. There's a difference. Science needs repeat testing. Amazing claims need amazing proof. A single report of math pulses from a star-traveling object is interesting but not final. Now, here's where the story takes a darker turn. According to claims spreading in the same circles, NASA's Solar Dynamics Observatory went offline on October 13th. The SDO is a spacecraft that watches the sun all the time. It provides real-time pictures and information about sun activity. If you wanted to watch something near the sun, SDO would be one of your main tools. The claim is that SDO's public information feeds went dark on the same day Sarita reports seeing the Fibonacci pulses. Coincidence? Equipment breakdown? Purposeful action to prevent checking? Let's check that claim. NASA usually announces when major spacecraft have technical problems. They keep status pages. The science community would notice if a main sun observatory went offline. So either this happened and was publicly known, or it didn't happen and this is false information. Or it happened in a way that hasn't been widely reported yet. The same claims mention that Mars high-resolution picture systems have been unavailable since October 1st, HIRAC. The high-resolution imaging science experiment on the Mars Reconnaissance Orbiter can take detailed pictures.